Thank you for watching the Rolls Battery Engineering Training webinar series. Today we are going to talk about tips and tricks when using Outback products on Rolls batteries. This applies to the flooded lead acid batteries only. If you use these settings for AGMs or the gels, you're going to cause problems with the batteries and overcharge them, so please do not. My name is Steve Higgins. My contact information is on the screen. If you have any questions, feel free to contact me. I'll be more than happy to help you out wherever I can. A little bit of housekeeping. We try to keep these to 30-40 minutes. Actually, this one should be right around 20 to 30 minutes the longest. I've muted everybody's microphone so we don't get echoes. And if you don't have access to the chat pane, please email me directly, steve@strut.com. I'll be more than happy to help you out. All materials for this webinar and all of our other webinars are available for download. They are currently stored on Google Drive. Here's the link. I don't expect you to click on this link, but if you send me an email, I will give you access to this Google Drive. I will also give you a link to our YouTube site and invite you to future live webinars. So what we're going to talk about today is Outback inverters, Outback products, Outback charge controllers, the FlexNet DC. We're going to talk about this specific system, 16 S550s, 856 amp hour battery bank. That consists of one string in series with two strings in parallel. So it's a total of 16 batteries connected, 8 in series with 2 strings in parallel. We're going to talk about 6,000 watt solar array connected to 2 60 amp MPPT charge controllers. We're going to talk about the Outback radiant inverter, which is capable of a total of 120 amps of charge current. And then we're going to talk about the FlexNet DC, how to do programming. Some of the highlights, we're going to discuss minimum and maximum charging currents. We're going to discuss charging voltages. We're going to discuss discharging currents, what you should watch out for when you're discharging these batteries or when you're loading the batteries. We're also going to talk about estimated peak solar production in January, July, August, different times of the year. And then, of course, we'll talk about what you're really going to see in the average charging current. Very rarely are you going to see max charging currents unless you're at the beginning of the bulk stage. Okay, so on this particular battery bank, we have 16 S550s configured at 856 amp hours. Basically 2 parallel strings of batteries. What would be the minimum and maximum charging current for this battery? Well, for flooded lead acid batteries, your minimum, you want to have at least one charging source that is minimum 10% of the C20 rate, which means I want to have one single charging source minimum of 86 amps. And the reason for that is that limits your absorption time. That takes your absorption time to just over 4 hours of time. The maximum charging current is 20%, and that 20% gives you an absorption time of just over 2 hours. And so you want your absorption time to be in this window, because what will happen is that if you keep to these limits, these minimums and maximums, you're going to ensure that those batteries see a relatively full charge almost every single day. The number one problem with most systems is customers let the batteries sit in a state of discharge over long periods of time, and that's the number one reason which causes you to have to replace battery banks fairly quickly. One of the big differences between a valve-regulated lead acid battery and a flooded lead acid battery is a flooded lead acid battery has a higher internal impedance. That higher internal impedance, if you go over that 20% number, what will happen is that will cause problems with the positive plate. It will actually cause the positive plate to expand. So if you've ever walked into a battery room and you look at the batteries, and on a few of the batteries or all the batteries, the positive posts look like they've been like they're rising up out of the battery. That's called positive post expansion, and what causes that is heat. Too much heat will cause the positive post to expand, and that'll cause the battery post to rise out of the battery. So that's what you want to try to avoid. So try to stick on a flooded battery bank, 10 to 20%. So minimum and maximum discharge currents. Try to keep your discharge currents less than the C20 discharge rate. Now this is the spec sheet. This is what the spec sheet says for the S550 batteries. And if you notice, we have two parallel strings of batteries. So what that means is that you double this number. You double this 21.4 amps. So that's actually 42.8 amps. 42.8 amps works out to be on an AC system at 48 volts. That's roughly right around 2,000 watts of load. So with the inverter losses, it's about 1,900, 1,950 watts of load. And so if your customer's running 1,900 watts of load continuous, they're going to discharge these batteries when there's no sun or when there's no generator. You're going to discharge those batteries to 50% in 9 to 10 hours, ballpark, depending on where the full state of charge or the state of charging the batteries is. As you notice, the spec state of charging these batteries is 1280. If you started at 1265, you're going to be about 10-12% lower. So that 4 or 5 hours of what you expect is actually going to be closer to about 4 hours and 15 minutes to 4 hours and 30 minutes, ballpark. If you notice, the higher, the more load that you place on those batteries, the less the battery bank capacity. And so you have to keep that in mind. Where that becomes important to make sure you can understand it, make sure you can explain it, is if you install a system and the customer goes in afterwards and starts adding loads to the system, they're going to increase the overall load, which is going to lessen the overall backup time or the overall run time, and that's going to cause problems. It's better for the customer to go the opposite direction and use less load. In these systems, you typically find that the battery bank is much healthier and lasts longer than customers that end up running all this extra load. So try to keep your loads to less than the C20 rate. If you do that and you're properly charging your batteries, you should get a pretty long and healthy lifetime. All right, estimated peak solar production. This is probably one of my favorite. It's people who've dealt with solar for a long time. A lot of people, you get the phone call, I live in Arizona, I get 10 hours of sun a day, I only need 2,000 watts of solar panels instead of 4,000 watts of solar panels. Well, unless you're going to stick those solar panels on a tracker, you're not going to get 6, 7, 8, 9, 10 hours a day of production. You're going to get roughly around 5 to 7 hours a day of production. 3 or 4 of that's going to be probably at close to peak or 80 to 90 percentile, depending on what your insolation value is, what your watts per square meter is, the angle to the sun to the panels. So you got to be careful with that. Other things you got to consider: are you going to get that same production in January? You're going to get it in July, October, March. Different times of the year, you're going to get different productions based on your average daily sun, based on your temperature of the panels. All that affects the panels. So if you're in the Pacific Northwest or if you're in the Northwest Territories of BC, then what can happen is the wintertime, sometimes because of the colder temperatures, you can actually get better production than you would in the summer. So make sure you understand that. Make sure your clients understand that. That way my favorite phone call is the client that calls up and says, yeah, I'm in Arizona, I get 10 hours of sun, so I don't need that big of a solar array. Charging current from your inverter charger. Typically, you're going to see about 90 to 100% or close to it for the first 60 minutes in the bulk stage. Okay. After that, it's going to taper off to about 70 to 90% in the bulk stage. Once you get absorption, once you hit the absorption stage, your current's going to taper off quite rapidly, depending on what the state of charge of the batteries is or the health of the batteries. A sulfated battery, that's going to drop off to almost nothing fairly quickly. So that's where you've got to be careful with in-dam settings or battery capacity settings, because that could exacerbate the problems. So this 120 amp inverter, ballpark in the absorption stage, you're going to be right around the 80 to 90 amp range once you get to the absorption. So that's the number we typically will use for absorption time calculations. We'll get into that in a bit in a second. So for the charge controllers, so we have a 6,000 watt solar array connected on 2 charge controllers. Let's say everything's perfect, everything's pointed the right direction. Let's say in the bulk stage, we're going to take a reading and you're getting 100 amps of current. You can make an assumption there and guess Here, basically, I've derated it by about 15, 18%. And it can be as low as 30% deration. So I could use 90 amps, but for this specific case, we're going to use 100 amps. Ideally, what would be nice is while you're in the bulk stage, about halfway through bulk, measure the current and insert that number here when you're trying to determine your absorption time. And what that'll do is it'll give you a bit more accurate absorption time. It'll give you a bit more accurate number. For charging voltages, I would set both charge controllers up on this particular system because with Outback products, you can only really do increments of 0.4 volts when you talk a 48 volt system. And so I'm going to set your bulk absorption voltage at 60 volts DC, but you must be using the temperature compensation probes at 5 millivolts per degree C per cell. If you're not, you could damage the batteries. No matter where you are in the world, no matter if you're in the Mojave Desert, Hawaii, Alaska, Yellowknife, BC, Spring Hill, Nova Scotia, wherever you are in the world, you must always be using temperature compensation on your chargers. And the reason for that is when you're charging your batteries, you're going to see 10, 15, a 20 degree Fahrenheit or a 4 to 8 degree temperature swing for Celsius on your batteries while they're charging. If you're not adjusting your charging voltages up or down based upon the actual temperature of the batteries, you are never properly charging your batteries. If you're never properly charging your batteries, why should a battery manufacturer cover them under warranty? Keep that in mind. You should always be using a battery temp compensation. Something else to keep in mind is that in the summertime, you're going to have a little bit better production, maybe a little higher temperatures, but you're also going to have typically less use. People spend less time at home using loads during the summer. So you're going to see a little bit less use. So you might want to go a little bit lower in charging voltages in the summer. In the winter, people are in the houses more, they're using more power, but you have less production. So in the wintertime, you might actually have to go a little higher in voltages or a little higher in absorption times. These are things that you need to work out during the first year or two of the system by looking at the specific gravities and by checking and fact checking your numbers to make sure that you're getting those batteries to a full 100% state of charge, at least on a weekly or bi-weekly basis or bi-monthly basis. So keep that in mind. So on the charge controllers, just to review, I'm going to set my absorption or my bulk absorption voltage at 60 volts. I'm going to set my absorption timer roughly 3.5 to 3.5, 3.6 hours, roughly 3 hours 40, 3 hours 45 minutes. That's how I'm going to set that charge controller up. Now for the inverters, on the inverters, I'm going to set my charge voltage just a little bit lower than my charge controllers, and the reason for that is that if my charge controllers have sun, and for some reason I've gone through 3 or 4 days of bad weather, and my generator comes on before the sun hits the panels. Sun hits the panels, now both devices are starting to charge. What's going to happen is because you have your charge controller set a little higher than your inverter, what's going to happen is that your inverter is going to shut the generator off sooner. Don't manually go out, shut the generator off. Let the generator run because you need help. It's obvious that you need help to get those batteries. And the longer you leave these batteries in a state of discharge, the more damage that you cause those batteries. So it's healthier for the batteries. It's worth the fuel to do that. So I'm going to set my absorption voltage on my inverter charger maybe a little bit lower than my charge controllers. Again, I'm going to look at my current going into the batteries while I'm using my inverter charger. More likely, it's going to be around this 90 amps of current. Okay, so I'm going to use that number to determine what my absorption time should be. So my inverter absorption time should be roughly around 4 hours. If you notice, it was 3.59 hours for the charge controllers. It was 3.99 hours for the inverters. They are not going to be the same unless the charging currents are the same. That's another mistake that a lot of people make is they set the inverters and the charge controllers up at the same voltages and the same times, assuming that's where you put them, and the batteries never get to a full state of charge. So you need to be careful with that. Last but not least, we have our FlexNet DC. Now, what the purpose of the FlexNet DC is basically a trimetric meter. It measures the current going in and out of the batteries to help determine a state of charge reported on the meter. One of the problems with the FlexNet DC or any current meter is they use voltages calculations, and of course they depend on the customers to get the right settings. Now on the FlexNet DC, there's a couple of ways to program it. One thing you need to understand, end amps. End amps basically is return amps or end amps or charge parameters met amperage. What that is that when a battery, when you're charging a battery, so say you're charging an 856 amp hour battery, when your current going into that battery is less than 16 to 17 amps for an hour, for 60 minutes, that battery really is not accepting any more power. They are basically fully charged. So on the FlexNet DC, what you're going to do is you're going to set your end amps at ballpark 2% of that C20 rate, which is 16 to 17 amps. You're going to set your charge voltage parameter at 59.6, typically one step below your target. So 0.4 of a volt below your target. And then you're going to set your parameters met time at 60 minutes. And what that means is when your current hits 16 to 17 amps and your voltage is at 59.6 and it's been there for at least 60 minutes, the FlexNet DC is going to reset the state of charge meter to 100%. Okay? The same thing works for charge factor percentage. Okay? On a flooded lead acid battery, when they're brand spanking new, typically they're about 80% efficient when you're charging, which means you take out 100 amps, you put back 120 amps to get it full. Okay, so that the default on that comes out at 94%. That's too high. It's too conservative for a flooded lead acid battery. So typically your charge factor is 80%. If it were my system, after about year 3 or year 4, I would probably drop this a percent or two every year from there because, again, the batteries aren't going to be as efficient in year 3, 4, 5, 6, 10. So you might want to put a little more current in to make sure they get fully charged. That way it doesn't trick your FlexNet DC. Another way that you could program the FlexNet DC is you could set your end amps at 1.5%. Instead of 2%, you set your end amps down to about 12 amps, and then you leave this at 1 minute. That's just kind of another way to trick it. So you're setting it about 1.5, so that extra 0.5% is going to give you that time, and it should give you the time. The one problem with that is if your batteries are highly sulfated, I would be careful with that because what that'll cause is that could cause it to snowball into a bigger problem. If you go into a situation where the batteries are sulfated, low specific gravities, and your end amps and your settings here weren't quite right, set right from the beginning, one of the things I would probably do is disable this to 0, and so that way disable the shutoff so that it stays in absorption. And so you set this to 0 amps, you set this to 59.6, and you can set it out as far as you want, really, and then your charge factor. So that way the FlexNet DC isn't making the decisions on when to shut off your charge controllers and for programming. So at this point, basically you're done, right? You can walk away and never look at it again, right? Well, hopefully you picked it up earlier. The answer for that is no. And again, this is probably the #1 mistake that most people make when they first start doing battery-based systems, is that they go out, they install it, they collect the check, they drive away, and they never change the settings again. They never call the customer again. Okay? So what you need to do is 2 to 3 weeks after you've done the installation, you need to give the customer a call and say, hey, Joe, do me a favor. Take a look at your specific gravities and tell me what you got. So let's say this is only 12 of the 24 cells. Let's say they go to the batteries, or in this particular case, there's actually 48 cells they've got to check. So you start spot checking them, and they're all coming up, 40, 50 points low. We want to see a full 100% specific gravity on a battery bank that's being cycled on a daily basis. We want to see it fully charged at least once every 7 to 10 days, which means we want to see a 1.265 to 1.275 number after 2.5 to 3 hours of rest, after the sun's gone down, with light to minimal load. Okay, So if you go check the batteries at 6, 7 o'clock at night, the batteries are all 1260 to 1265. They were probably a little higher before. You're probably fine. But if you go to them and they're all 1228, 225, 235, 230, this battery bank's not getting charged. Either there's too much load running or there's not enough charging going on. Flat out simple. Simple as that. There isn't anything funky. There could be loose connections. There could be a lot of things that are causing this. So what you want to do is you want to recheck to make sure your battery charging settings are correct. You might want to put a current clamp on there and see what's actually charging. Put a FLIR on the batteries. Check the temperatures of the cells. Check the temperatures of the connections. Make sure you've got good, solid connections on your battery. Because if you don't, if this continues for months and months on end, that's going to exacerbate the problems, and the batteries are going to fail prematurely. And again, undercharging is not a warranty. It's not a manufacturing defect. It's an installation or customer defect. So be sure you're paying attention to that. So 2 or 3 weeks after the installation, you make some changes. So you adjust your charging voltages back, your absorption times up a little higher. You wait another 2 or 3 weeks, you should see a bump in these specific gravities. Okay. If you don't, then there might be bigger problems where the battery bank might be designed too big for the batteries. So be careful with that. In this situation, you're seeing 280s, you're seeing 1300s, you're seeing 310s, 320s. So you're seeing your specific gravities all pretty high. In this particular instance, which doesn't happen very often, especially in a solar application, you're basically overcharging. So what you're doing is you're putting too much charge in the battery. And what you're doing is you're pushing oxide material off the plates, making the battery more acidic than what it's supposed to be. This is like getting in your brand new car and taking it to the Indianapolis Motor Speedway and running the car at 250 miles an hour until the engine blows. Basically, you're overusing the battery bank. The battery bank's not going to last as long, and you're going to have issues. So in this case, what you do is you reduce your charge settings a little bit. You wait 2 or 3 weeks. You recheck. Then you recheck the specific gravities, every 2, 3, 4 weeks to make sure that they're dropping. Something else that this might be, check your hydrometer. Make sure your hydrometer is, properly taken care of. If you're using a refractometer, take some distilled water and calibrate your refractometer. Calibrate your hydrometer with distilled water and see if it measures 1, if you can go that low on your scale. I find a lot of times when people use the Easy Red or the clear plastic box style hydrometers, that can cause problems. That can cause issues with the accuracy issues for when you're reading your specific gravities. So keep an eye on that. So you'll need to adjust your settings down again. So at this point, if there are any questions, I don't see any questions. But if you do have any questions, please feel free to send me an email at steve@surrett.com. I'll be more than happy to help you out. If you're watching this on YouTube, if you leave a comment at the end, if you leave a comment below, either positive or negative, we will be more happy to address it. Let us know what we're doing wrong. I appreciate it. Anyways, you have a good day. Take it easy, and thanks for listening.